So now that we know how to convert between forms, it's logical to want to be able to evaluate logs or say what they're equal to. So I may give you something like this, log base 4 of 64. And I may say, hey, what's that equal to? Well, right now we don't know what it's equal to, so I'm going to write down equals x here, setting it equal to x. And then what I'm going to do is I'm going to rewrite it as an exponential, because those are usually easier for us to deal with. We're going to end up with 4 to the x power equals 64. And now it's just a matter of guessing and checking. If you just try 4 to the first power, 4 to the second power, etc., you arrive upon the answer x equals 3, because 4 to the third power equals 64. So this original log right here that I circled in green is just equal to 3. This green thing and 3 are identical because it's the exponents you actually get when you solve this. Kids will get lost after doing, like, some of these, like, what am I even doing right now? They'll just get kind of confused of the whole idea. The whole point here, write this down as a note for yourself, a log is just an exponent. What we're looking for in these problems is the exponent that gets you from here to here. 4 to the third power equals 64. That's all the log is trying to represent. It's the exponent that makes the problem work. So on our second problem here, setting it equal to x, we end up with 6 to the x power equals 36. And once it's rewritten like that, you can see, oh, 6 to the second power is 36. So your answer is 2. This log right here is just equal to 2. It's the power you raise 6 to get 36. On my third example, when you rewrite it, you end up with 49 to the x equals 7. And clearly on this one here, my answer isn't going to be a whole number. If you raise it to the second, the third, the fourth power, you're going to get bigger answers. So that leaves us with a fraction exponents or a negative exponents. And since the square root of 49 equals 7, that means that the answer, the square root, is the same thing as the 1/2 power. So my answer to this one is 1/2. Another way you could have done this here, 7 to the second power is 49. That means you kind of do the reciprocal here. It'd be 49 to the 1/2 power. On my fourth problem, we have to rewrite this as 2 to the x equals 1 over 16. Well, I know that 2 to the fourth power is equal to 16. And if you recall, a negative exponent sends it to the bottom of the fraction, so we end up getting 1 over 16. So the answer here is actually a negative 4, because it sends it to the bottom of the fraction. If you see 1 over a number, chances are you're looking at a negative exponent for your answer. My last problem in the video here, I have log of 100, but there is no base right here at all. It's just log of 100. So there is actually a log key on your calculator here. It's right next to the 7 button, so it's right there. So I'm going to hit that log button. You'll see it on the screen. Again, there's no base on this. And if I type in log 100, it's going to tell me 2. So if I were to rewrite this right here, I'm asking myself what number to the second power equals 100? The answer to that is 10. So this is called the common logarithm. It's the default log when you don't write a base. The common logarithm is base 10. So if you don't see a base on a log, it is base 10.